Okay, here's warm-up number 16. All right, let's simplify. So we're just going to be doing the multiplication on the first two problems. So on this first problem, I'm distributing. 2x times x is going to be 2x squared. Sometimes I see people write that as 3x, but that would be if you had 2x plus x, right? 2x times x is 2x squared. 2x times 3 is 6x. And it's simplified, right? If you can write it without parentheses and combine like terms, that's simplified. Okay, next up, I've got here two binomials that are multiplied together. So I'm going to use FOIL. You could distribute the x, then distribute the 3. And that's really what we're doing when we're foiling. It's just a way to keep track of the different pieces. Okay, so first means the pieces in front. So that would be x times 2x. And that would be 2x squared, right? Outer means the pieces on the outside. X times 1 is 1x, or just x. Inner, the pieces on the inside are 3 times 2x, that's 6x. And last, 3 times 1 is 3. Okay, and then I add up all of these terms. And I do have some like terms in the middle that I want to combine. X plus 6x is 7x. And there we go. Sometimes I see people get here and then say, oh, wait, I can factor this. And then they factor this. But that would put us back to where we started, right? So this is considered simplified when we've multiplied it together and written it without parentheses. Okay? All right. Number 3, most common algebra mistake of all time. I know I've talked about this before. Some people are going to just square both terms and say x squared plus 9. That's incorrect. Don't do this, because you want to think of this as a binomial times itself. So think of this as x plus 3 times x plus 3, which means we're going to have to FOIL it. So you can't just distribute an exponent into over a binomial or a trinomial or whatever. Okay? You have to think of that binomial times itself. All right, so foiling now. First, outer, inner, last. First, x times x is x squared. Outer, x times 3 is 3x. Inner, 3 times x is 3x. And last, 3 times 3 is 9. Add everything together, and again, we've got like terms in the middle here, so x squared plus 6x plus 9. Okay? So if you just squared both the terms at the beginning, you miss out on the 6x that goes in the middle. Okay? All right. Here I've got two binomials again, but don't FOIL because we're not multiplying these binomials. We're subtracting. We're finding the difference. So what you do want to do is distribute the negative inside the second set of parentheses. So I can write this without parentheses like so. Okay? And then I'll combine like terms. So I'm going to combine the x terms, and I'll combine the constants. And that is simplified. Okay? All right, next up, we've got simple radical form. All right? So, root 32, you can put that into a calculator. It's going to be 5 point something. It's more than root 25, less than root 36. Okay, but that's not simple radical form if you just do a decimal. What we want to do is break the 32 up into a multiplication problem. Now there's some different ones. You could use 2 times 16 or 4 times 8. It doesn't really matter. I'm going to use 4 times 8. Just pick any multiplication problem where the answer is 32. Okay. And then I want to keep breaking this up. So so what I'm doing here is looking for twins. So I could break up the 4, but I'm noticing that, hey, I can break up the 8 into 4 times 2. Okay? So I'm looking for twins, and it's true, I could break up the 4s further, and I'll show you how that'll work out too. So let's say you broke up the 4s as well. First 4 is 2 times 2. Second one is 2 times 2. So there's 5 2s altogether. I'm not going to bother with that because I'm noticing I have twins here. And remember, it's like the little story, if it's a jail and you got a twin, well, one of the twins can distract the guards and meets an untimely doom. But the other twin gets out, right? So one of those 4s is going to get out. And then if you don't have a twin, you can't make a jailbreak. And then so we've got 4 root 2, and this is simple radical form. Let's say you broke it up all the way up here. Well, I'm still looking for twins. There's a pair of twins, there's a pair of twins. That fifth 2 can't be, is just left out of the twin pairs, okay? So one of the 2's is going to get out from the first group, one will get out from the second group, and one of them is trapped in there. And then when you have multiple parts on the outside or inside, you multiply them together at the end. And you see I get the same result. So it doesn't really matter how you break up the 32 as long as you take out all the twins you can. They can be grown-up twins or baby twins. Doesn't matter. Okay. All right. Number 6. Well, there are no twins in the radical down there. Okay. So I can't take out any twins because I can't break down 5 anymore. But in simple radical form, you can't have a radical in the denominator. It's just the rules. So here's what we're going to do. Since we don't have a twin for the 5, we're going to clone one. So I'm going to do that. Okay, and I can do that as long as I do the same thing to the numerator. If you think about it, root 5 over root 5 equals 1. So I'm not changing the value of this fraction. I'm just changing its form because I'm just multiplying it by 1. Okay. Then when I multiply straight across, on top I've got 4 root 5. On bottom, I can put those 5's under the same roof. And then, hey, I've got twins. So one of those will get out and one won't. And then there's no one left in the jail. So I'm going to have it look like that. Okay. And then I'd also want to think about reducing. Some people will try to reduce to 5's, but one's in a radical and one isn't. So I do want to make sure I check out this part, but that's already reduced. 4/5 is reduced. So this is finished. It's in simple radical form. Okay. All right. When I've got a fraction inside a radical, you can break it apart like this. Okay. And then I'm noticing, oh, root 16. Well, the square root of 16 is 4 because it'd be twin 4's, right? So I got it down to this. So it's looking pretty good. But I still have a radical in the denominator, and there's no twins. So I'm going to clone a twin for the 3 down there. Okay, then multiply straight across. And that would be really the square root of 9, which would be 3, right? Which that's why this works. So that's one of those will get out. And then I've got 4 root 3 over 3. And again, don't reduce the 3's because one's in a radical and one isn't. All right, last problem. Let's find the zeros here. So to find the zeros, I'm going to plug in 0 for y. The zeros are very similar to the x-intercepts. They're the x values that will give you a y value of 0. Okay, so really they're the x-coordinates of the x-intercepts. All right, so I'm going to use, I don't have any common factors here, so let's use a modified diamond problem. So let's see, 4 times 9 is 36. I took the 4 and multiplied it by the 9. Now I can factor this new trinomial. Okay, I'm not going to list all the pairs, the ways I can multiply to get 36, but first thing that pops into my head when I see 36 is 6 times 6. Well, if those are both negative, then they'll add up to negative 12, right? So this is going to factor into x minus 6 times itself. Okay. Now we still need to modify the problem back since we modified the answer. So in the beginning I multiplied by 4. Now I'm going to divide the number parts by 4. Okay. So I got it down to that. Some people are going to take the 4 and pull it out in front of the x and say 4x minus 6 times 4x minus 6. Don't do that. You need to reduce first. Okay? Even though it doesn't reduce to a nice integer, still want to reduce this and then pull the denominators out in front of the x's. Okay? So, all right, let me move. I'm going to move up here. So now this would be 2x minus 3 times 2x minus 3. Okay, now I factored the trinomial. Now remember, that's all equal to 0. I wasn't writing that as I went, but I was just working on the right side of the equation there. Okay? All right, and now I still want to use the zero product property. So either 2x minus 3 equals 0 or 2x minus 3 equals 0, which they're both going to give you the same result, right? So I'm not going to do that work twice. So I'll add 3 to both sides and then divide by 2, and I've got 3/2, or 1.5 if you want to write it that way. And that's it for this warm-up. See you next time.